EMT smaller than metric designator 16 or half inch shall not be used. And then there is 3/8. MC is 3/8, and then, or 12/3 MC is 3/8. But then maximum size is 6. Number of conductors shall not exceed table 1, chapter 9. And then the bends just can't exceed 360 degrees. And then the internal diameter cannot be damaged. Anyone that's ever worked with EMT, if you have a hand bender that likes to keep things, stop using that hand bender or get it fixed or something. Also, when you are bending, make sure just make sure you're not getting the internal diameter ruined. It goes for all conduit, but EMT especially, it can happen and you can't notice it until you go to pull. Securing is supporting, fasten in place in accordance with falling at intervals not exceeding 10 feet. And then within 3 feet of each outlet box and so on. Obviously EMT is steel or metal, so it really doesn't bend. But I will say if you're using aluminum EMT, try and support it more often. Because even once you get number 10s or number 12s and the 3/4 or half inch, it starts to kind of bow a little bit. So just a recommendation there. And then sports, horizontal runs, 10 feet, obviously. Couplings and connectors used with EMT shall be made up tight. Where buried in masonry or concrete, they shall be concrete tight, or installed in wet locations, they shall comply with 314.15. Something to note, set screw fittings can technically be concrete tight. All you have to do is tape them. That's actually a manufacturer recommended install. But make sure you're using those correct manufactured type fittings. Another thing to note with that, with the connection into the box, the connector into the conduit needs to be nice and flush and all that. I know sometimes with EMT, we kind of, it is what it is. Let me just stick it in there, call it a day, but. And then also, can anyone tell me if 4 square boxes are allowed to be embedded in concrete?
If they're wrapped in duct tape, right?
Yep, wrapped in duct tape. That is correct. Duct tape's our friend, guys. Remember that. Yeah, if it's wrapped in duct tape or if there's fire putty around it. I have seen that. It's kind of weird, but yeah. EMT shall be made of the following: steel with protective coatings, aluminum, stainless steel. And then the marking, EMT must be marked every 10 feet. I have seen it, that the newer EMT does come with those markings. And, yeah, any questions on EMT? No questions? Okay. Well, let's move on. Flexible metallic tubing, pretty much same thing as liquid tight. Same principles apply, same with the grounding part. So I won't cover that. EMT, I'll cover EMT. So EMT or trade name SPRF tube. That's what a lot of people call it. It shall not be reconditioned, so you can't pull it out of the building and reuse it. EMT associated fittings shall be listed. Use is permitted. In any building not exceeding 3 floors above grade as follows. For exposed work, we're not prohibited. And then concealed within walls, floors, and ceilings. In any building exceeding 3 floors above grade, sealed within combustible or non-combustible walls, floors, ceilings, where the walls, floors, and ceilings provide a thermal barrier of material at least 15-minute finish rating as identified in listings of fire rated assemblies. And then here's an exception. In location where subject to severe corrosive influences are covered as covered in 300.6. In concealed, dry, and damper locations not prohibited, and above suspended ceilings where suspended ceilings provide a thermal barrier. Encased in poured concrete floors, ceilings, walls, and slabs, embedded in a concrete slab on grade where ENT is placed on sand or approved screens. Provided fittings identified for this purpose are used for these connections. For wet locations as permitted. Trade size, 1/2 inch through 1 inch, as listed manufactured pre-wired assembly. That would go for like a car harness. Some of them are ENT. And then with conductors or cables rated at a temperature higher than listed temperature rating of ENT. Its conductors, cables are not operated at a temperature higher than the listed temperature rating of ENT. Other thing is where tractor companies make their own manufactured harnesses. Sputnik, where we work at a lot, they make their own harnesses for all their equipment on site. They are journeyman electrician or apprentices there too. Do it. So I'm sure you guys can think of other manufactured. But pretty much ENT is kind of just replaces Romex at the end of the day. Obviously there's some gray area that you go into with it. We've used it in commercial buildings before, just to make it cheaper for the customer, mainly for data drops and things like that, because that cable will never exceed that temperature rating, hopefully. But if it does, there's a serious issue. But that's pretty much where we use ENT, as our company does. You can use it a lot of different places. Just the biggest thing with ENT, because you can go more than 6 feet. Make sure your bends don't exceed 360 degrees. That's extremely important. And then just like PVC conduit, remove the rough edges and flex and all that. Has to be supported every 3 feet and 3 feet within the termination point. If you want a nice, clean, straight run, you have to do more. Because if anyone's ever dealt with ENT before, it is most of the time it comes in a coil, and if it doesn't come in a coil, it comes on a spool. And trying to bend that stuff straight does not work. The best I've seen is people take a PVC heater to it or heat it up in some form. It does real good, but it just does not play nice. And then all joints have to be coupling or have to use the appropriate fittings for that. You can't just Smurf tube right into a plastic box. It just doesn't work that way. Unless the plastic box is ready for it. And then it's marked. And there is different types of ENT you can buy. Just like with PVC conduit and things like that, they have different ratings. And that's all this last one was talking about, so. Okay.
What were you saying when, you're talking about not going over 360, you said something like, since you can go over 6 feet or something.
So if you go back to like the previous class, when we talked about liquid flexible metallic conduit, sorry.
Yeah.
You can't go over 6 feet to your equipment connections, and that's really the only time you use liquid tight.
Yeah.
So,
Oh, so that's, you said you can't go over 6.
No,
Oh, no.
as per code, you can.
Yeah.
Right. Is there a gray area there where you're like 8 feet away? Is the inspector gonna say something for often not? I mean, like I recently did a house and it was pushing the 6 foot mark. But it was a cleaner install for the customer for me to just go straight out of the disconnect with liquid tight instead of doing a conduit bend and all this stuff. It doesn't, and it's cheaper for the customer. So at that point, you need to use your best judgment. And I even told the inspector, I was like, hey, I think it's like 6 foot, 6 inches, and he didn't care. So it's a gray area and depends on the inspector. So, yeah. But with ENT, you can just run it. Just run it. You can do whatever you want with it. Just make sure it doesn't exceed 360 bends. And it goes for what I said last week with PVC conduit, when you have all those bends, all the waves, it adds up and yeah. Like, for instance, in our shop, when we tried to wire some things in there, because it's all on Smurf tube, not real nice, like we expected. It made pulling wire through it interesting, to say the least, so, because it was definitely very wavy throughout the entire building. So, that's what I mean, Blaze. Auxiliary gutters. Yeah, let's cover them. They're not in class, well, but everyone uses gutters, right? So, listing requirements, outdoors, non-metallic auxiliary gutters installed outdoors shall be listed for the following conditions: exposure to sunlight, use in wet locations, maximum ambient temperature of the installation. Non-metallic auxiliary gutters installed indoors shall be listed for the maximum ambient temperature of the installation. Use is permitted, sheet metal gutters. Sheet metal gutters shall be permitted for indoor and outdoor use. And then sheet metal gutters installed in wet locations shall be suitable for such locations. When you go to buy gutters, it matches the exact same ratings as like a junction box. So you got your DMO 1 and the 3R, so on and so forth. So, yes, they do make stainless steel gutters. Are they very expensive? Yes, they are very expensive. I haven't had to buy them before. That is one you measure twice and go from there, because you do not just measure once. Extended distance of auxiliary gutters. Gutters shall be permitted to extend a distance not greater than 30 feet beyond the equipment that it supplements. And they do make, for NEMA 1 kits, at least for NEMA 1 gutters, they do make couplings and fittings and things like that you can buy, and they're relatively cheap. I can't think of any NEMA 3R ones or anything above that, because they're all handed and all that, but if you find one, let me know, please. I'm happy to look into that. Use is not permitted. Auxiliary gutters shall not be used to enclose switches, overcurrent devices, appliances, or similar equipment. Conductors connected in parallel or single conductor cables compromising each phase neutral or ground conductor of alternating current circuit are connected in parallel as permitted in 310.10G. The conductors shall be installed in groups consisting of not more than one conductor per phase neutral or ground conductor. Prevent current imbalance in parallel conductors due to inductive reactance. Who can tell me what that is saying? Go with Cameron Zaman. What do you think? Sorry if I butchered your last name.
No, you had it good. Is it like the cubic inches inside of it and you're not supposed to exceed 20% of that?
And that's part of it. It'll help you with that for sure. This has to do with AC theory. This doesn't even have to do with code at this point, just so you guys know. Let's give someone else a try. How about you, Carter? Carter Anderson?
Um, I'm really not 100% sure. My closest guess is you really don't want to have more than one uh set of wires in it for whatever harmonics reasons. I'm not 100% sure.
Okay. Okay. All right, I'll go ahead and explain it to you guys. You guys have good things to say, that's for sure. Definitely good things to think about. But when you have parallel runs, the reason why you don't separate the phasing, so if you have a parallel run of two, you don't put A and B in one conduit and then C in a neutral in another conduit. It's because you're gonna have magnetic force between those conduits that twists around, and you'll have weird inductance and reactance and all that. So that applies to gutters, right? So when you do your parallel, you don't want all your A phases together, all your B phases together, and all your C phases together inside a gutter. You want to make sure they're still all together. Ideally, they'd be twisted together, but most of us don't deal with twisted wire. So you at least group them together. So you'd have your A, B, C, and your neutral for that one parallel. You group that together. And the reason for that, that keeps that magnetic force together from the phase shift and all that, the AC theory. That keeps that all together so it doesn't jump to another with the same parallel run, it doesn't jump to that one. So that's why you keep that all together. I could say you could test this, but to test it in an actual like way, you would intentionally have to mess up like a service. So I don't recommend that. But you would see a weird voltage ratings. Your power factor wouldn't be as good either. And you would also, if you had a harmonic or a, trying to remember what that device is called. It's like it's layman's terms called like a power meter. It reads the power and all the harmonics on it and all that. But you would see a lot of harmonics come on two of those as well. So, but that's why you always group everything together. Even if you're just running branch circuits, you make sure all your branch circuits are grouped inside the gutter as well and all that. So. Yeah, Tyler's correct. Yep. But you would get a lot of weird things going on. You'd also get voltage on your neutral, which is not good. So. So that's what that's saying. And this one's a hard one, because if you are just doing distribution out of a gutter, you're gonna have to break it apart at some point, right? So just try to keep them as grouped as possible until you do the distribution, and then you can fan out from there. And that just comes into if you're tapping for thinking motors or thinking something like that, so. Also some utilities, well, even Iowa Power still has some old services like that. And some commercial buildings where they'll tap out of inside of a gutter and hit multiple meters. And services like that, so. And also can't exceed 20%. So if you do keep them grouped together, it's gonna be nice and tidy. And I'll be honest with a lot of you, I've seen a lot of gutters that are look full to the brim and they still don't meet the 20% rating, so. We've done the math, we even had the inspector do the math, and it still didn't exceed, even though you couldn't get another set of number 12s to it, so. It's extremely difficult to meet this, so at that point, you would need to do temperature derating and go from there. So the adjustment factors in 310.15 C1 shall be applied only where the number of current carrying conductors, including neutral conductors, classified as current carrying, exceeds 30 at any cross section of the sheet metal auxiliary gutter. Conductors or signaling circuits or controller conductors between a motor and its starter and used only for starting duty shall not be considered as current carrying conductors. So just real quick, signal circuits like fire alarm, things like that, and then a starter, so stop circuit. So it literally just is just a start-stop circuit. There's no other current going through it until the only current going through is when you push that start button. And that's the only time the current goes through it. Shall not be considered the current carried continuously in bare copper bars and sheet metal auxiliary gutters shall not exceed 1.55 amperes squared, 1000 amperes inches squared of cross section of the conductor for aluminum bars. The current carried continuously shall not exceed X. So that's for manufacturer, just so you guys know. Unless you do install like bus duct. And that's when that would apply and you might have to do the math. Most of the time, if it's a bus duct installation though, it's been engineered, so you guys shouldn't have to worry about it. So. But, so this also covers, technically would cover your busing and your, panel boards or load centers and distribution panel boards, and then also your switch gear, motor control centers, things like that. Or if, some control boxes have busing in it, that would also be covered with that too. That's why there's certain spacing and all that between busing and all that. The adjustment factors specified incur the current carrying conductors up to 20% fill for non-metallic. Securing and supporting sheet metal shall be secured throughout their entire length at intervals not exceeding 5 feet and then 3 feet non-metal. However, I will say if you have feeders going through your gutter, support it more. Seriously. For instance, at Sputnik, we had to do a double stack gutter below these panels because they wanted it all underground. And one gutter was for feeders and one gutter was for just branch circuits. And we ended up actually having to do metal support bracing from the floor to support these gutters. I mean, these gutters were probably, I don't know, maybe 12 inches from the floor. So it wasn't that much, but we still had to do that support. We also had to do reinforcing steel inside the gutters, just because there was so much weight from the feeders in there. Yeah, this was a lot. It was about, that service was, I think, for the new building, I think it was almost 4,000 amps. So just think about 4,000 amps distributed into a bunch of different panels. It was a lot, so. Even though code says you just do every 5 feet, should you do every 5 feet? No. That's a great example of it. They do make expansion fittings for gutters. Have I ever used them? No. Do I think you should ever have to use them? Probably not, unless you're doing bus duct. Within gutters, splices or taps shall be permitted within gutters where they are accessible by means of removable covers or doors. The conductors, including splices and taps, shall not build the gutter to move gutter to more than 75% of its area. So that goes for like using distribution blocks as well. The biggest part with distribution blocks is making sure you have enough depth on your gutters. Does it make it a lot cleaner than doing like Polaris lugs and split bolts and all that? Yeah, it does. So. Taps from bare conductors shall leave the gutter opposite from their terminal connections, and conductors shall not be brought in contact with uninsulated current carrying parts of different voltages. So that goes for bus duct mostly. Because bus duct is uninsulated bus bar. Is literally bare copper inside those, so. All taps shall be suitably identified at the gutter as to the circuit or equipment they supply. And then overcurrent protection for your conductor, for the tap conductors. Insulated conductors are deflected within the auxiliary gutter. Either at the ends where the conduits, fittings, or other wasteways or cables enter or leave the gutter, or where the direction of the gutter is deflected greater than 0 degrees, dimensions corresponding to 1 wire per terminal. So that's just bending radius, essentially. Where insulated conductors four aught or larger are pulled through an auxiliary gutter, the distance between the raceband cable entries enclosing the same conductor shall not be less than the required 314.28A1 and A2. Who remembers those multipliers? These are important multipliers to remember. Go with Dylan Gobble or Gobble. What do you think?
I was just looking them up really quick to remind myself what they were.
Okay.
Mm,
We will wait.
Minimum wire bending space at terminals and minimum width of wiring gutters. Oh yeah, okay. Sorry, what was the question again?
So what is the multipliers for straight poles and angle poles?
Oh, let's see.
So it's for knocking out your box or gutter.
Mm. Where's it? Sorry.
No, you're good.
Um,
Unless you found it right now. I'll save you some time, save us all time. So it's 6 and 8. So straight poles is 8 times. And angle poles is 6. At the end of the day, as long as you follow that, the 8 and 6, you're not gonna have to worry about your bending radius on your wire. Unless you're doing tray cable, and that's a whole different beast. But that's a super important one to remember. So let's try and remember just 8 and 6. And if you can at least remember that, then you know, okay, I can just look up straight and angle and then you know which one's 8 and 6. So grounding. Metal auxiliary gutters shall be connected to an equipment grounding conductor, to equipment bonding jumper, or to the grounding conductor where permitted. And then construction. Things continuity, no rough edges. Would have substantial construction, and then clearance of live parts. And then it has to be marked for its use. From factory. Those markings are usually like right in the center on the inside. That goes for most J boxes or any kind of metal box that you use. Except for a Foursquare. Foursquares can be weird. Any questions on gutters? Not even code related. So as you can see there, you can get away with a lot with gutters at the end of the day. Gutters are either an extremely useful tool or they are a complete dumpster fire. I've been in a lot of gutters that I wish I'd never been in because, oh boy. And then the other issue with gutters, if you don't group things correctly, like the branch circuits and stuff like that, it can be extremely hard to find that one circuit going through that gutter. Because even if you put a, what's it called, circuit tracer on it, it'll jump to other circuits. So circuit tracers nowadays are pretty smart now, or even toner. They're pretty good now. But they can jump and they can get annoying real fast, so. Make sure your gutters are nice, clean, and usable, and can be service friendly for adding or service, so. Who here has installed a bus duct? Anyone? I know we have. You guys remember? Remember that flexible bus we installed?
Let's buzz.
Mhm.
That's stuff.
Yep, that's a type of bus duct. It's flexible, it has insulating, pretty much. So what I'm talking about is we installed Flex Bus in out at Simplot. And it was actually the second in the nation, second install in the nation. Because it was just barely getting UL listed for US use. It's been installed everywhere in Europe and in like control cabinets and things like that. But it's essentially just very, very, very big wire. That's what it really is. A bunch of fine strands and all that. I'll actually bring a little piece that I have at home for you guys tomorrow or next week, sorry. So you guys can see the inside. I don't have the big chunk of it, but I do have a little brand of it. So. If no one's installed bus duct or busway, I'm not gonna cover it because it's not really used anymore. A lot better things out there. And if it is used, it's a very specific thing and your company is very used to installing it. So it's a very niche thing. Okay, feels nice. Metal wireless. Same thing as gutters. Metal wireways, same as gutters, pretty much. They have so metal wireways is like, you know what, let's just go. So cellular concrete floor raceways, cellular metal floor raceways. And metal wireways and non-metallic wireways are essentially the exact same thing, just different ways or different permissions and things like that. So we'll just cover metal wireways really quick. So metal wireways would be like your wire mold for instance. Has anyone dealt with wire mold before? I'm sure there's a chunk in this building somewhere. You could find it. ISU has a lot of it. But use is permitted for exposed work in any hazardous classified location, as permitted. In wet locations where wireways are listed for the purpose and concealed spaces as an extension that passes transversely through walls if the length passing through the walls is unbroken. Access to the conductor shall be maintained on both sides of the wall. Can anyone explain to me what that means? I mean, it explains it really well, but I just want to make sure everyone understands what that's actually saying. Go with Nathan Kent. What do you think?
Just if you're going through a wall, don't splice it onto another piece. Has to be one continual piece.
Yeah, exactly. Like I said, it explains it really well, but just want to make sure everyone understands what that means, because yeah, you can see it in ISU where they do it, but so it just has to be one continuous piece through that wall, so it's like pretty much running conduit right through a wall. That's essentially what it is. And the reason why it's important that you have access to both sides, because there is a cover on it. So you have to be able to access both sides. Can't just be buried behind a wall. Can't just run it inside a wall or whatever, so. Use is not permitted, we're subject to severe physical damage, we're subject to severe corrosion environments. So severe physical damage would be like below, 4 feet or whatever. Because you'll also see in ISU that they use it for access control. And conductors connect in parallel, the same. And then this one's also 20%. There is a D rating table for wireways. So make sure you understand it. Because it is a lot different from conduit, I think. If I remember right, the maximum you can go with number 12 is like 26 of them in one wireway, so. That also depends on the size of the wireway. And wireway that I'm talking about is not very big, but if you get into like like what they call a 4 duct system, that's when it can get pretty big. But they typically go. Well, they're not your standard sizing. It's not like conduit, but I think 1 5/8 is a very common one, and the depth is like 1 inch or something on it. So just keep that in mind. It has to be supported every 5 feet, and then vertical support every 15 feet. If you do vertical supporting every 15 feet, don't do it more often. The thing about wireway, typically it is installed in a public view area and is subject to people bumping into it. So support it more often than it says. These are just my notes. Remember that, guys. Am I saying go crazy and do every foot? No, but try and support it more often. Power distribution blocks, live parts, conductors. You must use dead ends for your wireway. You can't just leave it open. And manufacturers do make metal wireway extensions. They make boxes for them. They can just go right into, things like that. Or even really hard 90s. And then it just talks about construction and marking. Most of the time you install a wireway, guys, is your last resort typically, unless it is specifically called out. Another thing to think about with wireways, it is also like, plug strips. Some big old plug strips, those are considered wireways as well. Especially if it's the ones that we assemble on site. Another one would be like what they call a telephone pole. Or a drop poles. You'll see them not typical around here anymore. They've done away with a lot of them, but near cash registers, that's a big one because they have a separate compartment. One's data, one's power. They drop down on both sides. It's not typical, but you can put in receptacles into those and they can power things off of those, and same with data plates and things like that. But typically you'll just drop it down. You'll run MC through it or just Cat5 or whatever, and then you'll just go to whatever box they wanted, wherever they wanted it. That's how those typical installations go. But any questions on metal wireways? Okay. Multi-outlet assembly is what I was talking about. It's pretty much the exact same thing. They do make, you can use strut as a raceway. They do make covers for it. Typically, you'll only ever see that used as a raceway is maybe in an industrial facility or sky rises. So, but you can do it, but it's very, very expensive. Very expensive. Underfloor race was pretty much the same. And then surface metal raceways is the same. It should be the same fill and all that. Okay. Let's go to everyone's favorite. Article 392. So who has installed cable tray besides the people I know have installed it? Cable tray meaning the basket tray is another one. Ladder type tray. That's typically what we install. It's just fiberglass. It's ladder type. And then there's also rung type. If you work for System Tech, you probably have dealt with it. System Tech typically buys a black ladder type tray for their server rooms if they need it. And then you have probably, if you work for System Tech as well, you probably have used basket tray as well. Or installed it. So the hard part about cable tray is mostly what is the fill, and then how do you ground it? So obviously, if it's not metal, don't ground it. That's simple. The fiberglass cable tray that we work with Simplot, we don't ground it, but we ground the structure around it. That makes sense, because once you get a bunch of big cables in the cable tray, it gets kind of heavy. So you end up having to ground the steel structure. And with that being said, with basket tray, technically you're supposed to ground it. Like, I think it's pretty often. And they do make fittings and all sorts of stuff for that, for basket tray. So use is permitted. Cable trays shall be permitted to be used as a support system for wiring methods containing a service conductors, feeders, branch circuits, communication circuits, control circuits, signaling circuits, single insulated cables and single insulated conductors shall be permitted in tray only when installed in accordance with 392.10B1. Cable tray installation shall not be limited to industrial establishments where exposed to direct rays of sun, insulated conductors, and jacket cables shall be identified as being sunlight resistant. Cable trays and their associated fittings shall be identified for the intended use. And it goes through the list of wires and all sorts of stuff that you can do. So as you can see, cable tray ties into a bunch of stuff. It really does. And it's probably one of the best ways to, instead of doing a conduit rack, like you'd see in a commercial building. And then industrial, that is your conduit rack essentially. So for the only time you'll really see cable tray get used as a conduit rack is typically in an industrial setting. Trying to think of any other place where we've done it. But really simple, place we've really done it. We did offer to do it at Sputnik when they were building their new expansion, but they wanted everything underground, so they got everything underground. I will say at Sputnik, just real quick, at Sputnik, there's about 10 miles of PVC conduit underground, under that building. Yeah, those trenches were, you could fit a car in those trenches. They were huge. And then we had to dodge footings, like massive footings. So it was definitely kudos to that journeyman foreman that did that. So did a great job. But in industrial establishments, the wiring methods in table 392.10A shall be permitted to be used in any industrial establishment under the conditions described in the respective articles in industrial establishments only, where conditions of maintenance and supervision ensure that only qualified persons service the installed cable tray system. Any of the cables in 392.10B1 and B2 shall be permitted to be installed in ladder ventilated trough, solid bottom, or ventilated channel cable trays. So the ventilated trough and the solid bottom, most manufacturers classify that as a wire width, just so everyone understands that. And then the ventilated channel cable trays is just holes along the side. It looks like slotted strut, essentially. If anyone's ever dealt with cable tray. Single conductor cables and single insulated conductors. Single conductor cables and single insulated conductor cables shall be permitted to be installed in accordance with 392.10B1A through B1C. Single conductor cables and single insulated conductors cables shall be 1/0 or larger and shall be of a type listed and marked on surface for use in cable trays where 1/0 through 4/0 single conductor cables and single insulated conductors are installed in the ladder cable tray. The maximum allowable rung spacing for the ladder cable tray shall be 9 inches. So for my coworkers, now you see where the 9-inch part comes into play. Because they want to be able to run single conductors in those trays if they need to. And then welding cables shall comply. And then single conductors used as equipment grounding conductors shall be insulated, covered, or bare, and they shall be number 4 or larger. We don't have to worry about that because we typically run 4/0 through all of those trays and then tap off. But who can tell me which type of how can I explain this? What color of insulation is sunlight resistant for any type of single conductor.
XHHW,
Huh?
XHHW,
Yeah. Yeah, but what color? Because color does matter. Color's black. Black is the only color that is sunlight resistant for any single conductors, and then also the minimum size that manufacturers make sunlight resistant single conductors in is 8, number 8. So anything below number 8 is not sunlight resistant. Keep that in mind. That's a good guess on the XHHW. XHHW is definitely, I would say, sunlight resistant, doesn't matter the color, but the manufacturer does not put it on color to XHHW that it is sunlight resistant. And especially for THHM. But and that's why when you see like an overhead line, it's always black. Only black for this. Okay, single and multi-conductor cables still being installed in accordance 392.10B1, so it follows the exact same article. And then hazardous classified locations shall contain only the cable types and raceways permitted in other articles. So as you can tell, cable tray does not care. Obviously, you're not gonna use steel tray in an acid area, right? Because they'll just get eaten away. That's why I was thought we use fiberglass tray, and we actually use a higher type of fiberglass. There are 2 types for that tray. There's vinyl ester and polyester. We use vinyl ester because it's thicker and it's more dense, and then also it's just a better product, and the coating they put on it is a lot better too. Like that being said, the tray itself doesn't care. It is literally the cables or conductors you're running in that tray. That's when you have to care about the hazardous location. Airfield lighting cable tray. In airports where maintenance and supervision conditions ensure that only qualified persons can access, install, or service the cable, airfield lighting cable used in series circuits that are rated up to 5,000 volts and are powered by constant current regulators shall be permitted to be installed in cable trays. So anyone done an airfield lighting install? Yeah. The most I've seen is an actual bid on one, and it was all just underground. So I'm sure at like the international airports, they have some sort of this, something like this. But I haven't personally seen drawings on it. Use is not permitted. Cable tray systems shall not be used in hoistways or subject to severe physical damage. So. So hoistways being below a bridge crane or yeah, so this is where things get hard because I have coworkers in here say, that's not true. Because where we have installed it before. But here's the problem with a lot of this is industrial establishment can be like, oh, only a qualified person will be servicing it, so it don't matter. So that's where you can throw the code book at. We have installed tray in hoistways, but it is not above equipment that can be hoisted. Does that make sense? So there should be no possible way for that tray to get damaged. Even this new building we're building, we literally have, there's a pipe rack that were built right on top of. And, it is in the hoistway. The pipe rack is in the hoistway as well, so. But there's no way that that piece of equipment will be hoisted above that tray. That's why it's allowed. The workers understand that. Cable trays have to be in a complete system, just like any other raceway. I will also get some hate for that one from coworkers as well. Derek knows what I'm talking about. But, technically, the way we're doing the install out there, it is still a complete system. And those not necessarily. Yeah, I won't go any further, but. It is still technically a complete system and a complete raceway, because the cable can still flow. Quite well, so. And then portions of runs where additional protection is required, covers and enclosure, providing the required protection shall be of that material that is compatible. And then completed before before installation. Installation of cables. We, out of Simplot, they're. How can I put this? So. We've been slowly upgrading the electrical rooms out there at Simplot. So in order to be able to do all the work we have to do within a month or two. My coworkers can attest to that. We do work our asses off for this month or two. We have to run tray outside and then pull the cables and have them ready to go inside the MCCs. So technically, what we're doing is against code because that raceway is not completed, right? But in order to do it in a timely manner for that shutdown of the plant, we have to have those cables ready to be pulled into the MCC, and then we can complete the raceway inside the MCC from that point. So there's give and take there with the code. Any inspector, well, the older inspectors would tell you that's perfectly acceptable as long as your cables are protected. And we do make sure that our cables are protected the entire time. And quite frankly, if someone can mess up air guard, they are using a skid steer or something that is very heavy. Because I've seen lifts run over it and it's still just fine. So. So just keep that in mind. Keep in mind of the facility that you're in and working at for these types of installs as well. If you're in a brand new building or commercial building, make sure the raceway is completed. It's not that hard, even out of Simplot, we are doing a brand new building out there and the raceways will be completed before we start running the cable. That includes the conduit drops down from the tray. So. Okay, through partitions and walls, cable trays shall be permitted to extend transversely through partitions, just the exact same way as the waterway. Exposed and accessible, cable trays shall be exposed and accessible except as permitted by 392.18. Shall have adequate access. Raceways, cables, boxes, and conduit bodies supported from cable tray systems. This just goes on saying that it's common in industrial facilities and just leave it at that. And unless you are 100% supporting your cable tray, do not support anything on it. And what I mean by that is like out at Simplot right now. We literally have another contractor that is welding angle iron below our tray, and have angle iron trap pieces that support this. And the tray is 100% supported. That has essentially they are building a metal cable tray underneath our cable tray to support it. It's essentially what they're doing, just doesn't have runs. So with that being said, that is now considered like a structural support. So now we can actually support off of that. So just make sure we're not, I don't know, if we are using a trapeze or inside the MCC, for instance, let's try not to support anything else on off of it, for instance. Or whatever our trapeze would be rated at, which is a lot, by the way. And just for my coworkers, 3/8 and 1/2 inch all thread has a, I don't want to say shear strength, it might be shear strength. But I think it's shear strength, that has shear strength of like 50,000 pounds or something like that. So really what's gonna fail and whatever our trapezes are inside is the nuts and the washers and the strut. The strut's gonna fail before the all thread. And strut for a 3 foot span, 1.5/8 strut is slotted is rated at like 2,000 something pounds, so. As long as we don't exceed that, we'll be good. So that's how the engineers would go about designing something like this. So, and then marking has to be marked, danger, high voltage, keep it away. That's another thing that you can get away from inside a industrial establishment, which is the reason why we don't do it out there. That is because every employee out at Simplot is trained and understands if we see a tan square shaped looking thing, don't touch it. It's pretty much what they're trained to do. And then their crane operators out there are obviously trained not to lift over it. For this new building though, we will be labeling it, just so you guys know. It's gonna be fun. But cable and conductor installation, multi-conductor cables operating at 1,000 volts or less. Anything 1,000 volts or less shall be permitted and installed in the same tray. If it's over 1,000 volts, it has to be separate. Or no. Yeah. Yes. Even though it says you can have combined voltages, the insulating jacketing for those cables have to be rated at 1,000 volts. So even though, say I got, I don't know, 600 volts in this cable, 480 volts in this cable, and just say 208 and 120 in the rest. Every single one of those outside insulating jacketing for that cable has to be rated at 1,000 volts. Doesn't matter what kind of voltage going through it. Otherwise, you'll have some weird voltage leaking. I have seen it. Like I've discussed in the past. Even now it's Simplot where we do have the divider in there, dividing the 480 from the 120, and we have, no, we don't separate 120, but 480 and the 120 and the instrumentation. Even inside the 480 volt, you can see weird voltage fluctuations, and then inside the 120 controls, you can see weird voltage fluctuations as well. Like for instance, there's no amperage on this, so testing it should probably fine, but when we were doing some troubleshooting on some start-stop circuits, for a circuit that was supposed to be dead, and it was, I was seeing 50 volts to 70 volts. And that's just because of how much current and the amount of cables that are going in that tray. And that's just an induced voltage, and that's what happens. So if those weren't rated the same insulation, I would probably see 120 volts or whatever the voltage is with that. That makes sense. So it's extremely important to make sure your insulation is matching with each other. If you do this. And then connected in parallel, just follow the parallel rule. And then where any of the single conductors installed in ladder are ventilated through trough cable trays are 1/0 through 4/0, all single conductors shall be installed in a single layer. Conductors that are bound together to compromise each circuit group shall be permitted to be installed in other than a single layer. So what does that mean, guys?
They can't like stack on top of each other.
Exactly. So blaze, perfect. So if it's a single conductor run, it can't be stacked on each other. They have to be on the same layer. Does that make sense? So for my coworkers, if you worked at the project, as you can see above the switchgear and the MCCs, they're all in one layer, right? They're not crossing, not going over top each other. And that is because of this. So. And even though we are technically, the manufacturer specifies that this, what we're using is a cable. It is still single conductors just twisted together. So. That is why we are still doing what we're doing. And then this is just the number of conductors and cables, and then this has your load calculations essentially. The key word here is inside width of the cable tray, not outside dimensions. And cable tray is, if you're using cable tray like we do, there's essentially two C channels on the sides. And then there's rungs in between that hold it all together. So the inside of the C channel from top of the rung is your low cap. That makes sense. So when it says more typical, what we install out there is 6-inch high cable tray. So from top of rung to the bottom of the C channel lip is 6 inches, or should be close to 6 inches. So
That's the width.
not the width, but the width would be 36 inches or whatever, 24, 18, 12, sorry. But yeah, but you go up the height and then your width, the width is on the inside, not the outside.
Okay.
And then it's a top of rung. So. It's always above the rung, remember that. But if you guys want to do those calculations, that work one of these days. It'd be surprising. Tray's a little, as you can tell, to keep cable tray from becoming what a gutter usually turns into, there are rules into making sure your cables are nicely trained inside. There are literal code sections for it. So. And then I'm gonna skip this signal cables. And then also small bottom cable trays. A lot of people won't ever deal with it. So. And then a lot of people won't deal with vented channel cable tray. But we do deal with solid, so. So this is the allowable cable fill. These are just basic calculations for you. I will tell you guys now, this is more for engineers, not for us. Then this number of single conductors in a tray, ventilated channel cable tray types, and the number of medium voltage and MC cables, 2000 volts and higher. We do with medium voltage out there. I'm sure everyone's had a hand in it that has worked out there. But the voltage, the medium voltage we deal with is 4160. Is the voltage we deal with. Obviously, Idaho power coming in is gonna be way higher, but that's what we deal with. So. But that's always gonna be engineered. So don't even worry about doing any of that. But then cable trays shall be supported at intervals in accordance with the installation instructions. Every single manufacturer has different installation instructions. They try to make it easier for everyone and try to be similar, but there's those little niche things about them usually. And then you do have to install expansion splice plates. Now. Out at Simplot, we don't do the typical expansion splice plates because we did do an install with expansion splice plates and the splice plates ended up just breaking apart out there. Because the expansion and contraction is just so much for them. And really all they are for the tray we buy is just elongated holes. So they don't do nothing really. They only allow this way, they don't allow this way, right? So we found that just leaving the bolts loose and just the regular splice plates. It's good. So and that just allows for just whatever movement that it needs. Because out of Simplot, just for everyone's reference of what I'm talking about, I say recently, but this was actually years ago now. They did a new Idaho power expansion essentially. So we did a big old bridge structure that refed all the electrical inside the facility and put it all along that bridge structure. And that's where we use the expansion splice plates, and a lot of them broke off. So even during construction. So, and to give everyone a reference and an idea of why this is important and deflection is important to keep in mind is because these bridge structures are typically 40 feet in the air and the steel itself moves. And this is big steel. Like you could try and take a tank to it and it would not fall over kind of steel. And these footings go 20 feet in the ground. And they're about, I don't know, what do you think, 4 feet by 4 feet, most of them? They're big footings. And the fact that that big structure moves, not even just from wind or anything like that, but from thermal forces. Obviously, our little tray up there is gonna move, right? It's gonna move with the structure at the very minimum. So that's why that is important. With that structure, bridge structure as well, we also ran 6-inch fiberglass conduit. And we had to put expansion coupling, I think it was like every 100 feet or something like that. And those expansion couplings actually do move a lot and they do their job very well. So. So that was definitely one of the, a very big project that we did. There's about, I'd say on that bridge structure, there's probably about, I don't know, 5 miles of fiberglass conduit on them, I think. Because there's a rack of 8 and then right below that is another rack of 8. So, a lot. Bush conduit and tubing. Just use bushings. And then cable splicing, you can splice some trays. And then it talks about metal cable trays and how you need to ground them. And the minimum equipment grounding conductor and so on. Like I said previously, we only use fiberglass out of where we work, but we do bond the steel that it supports it. So. Like I said previously though, most people will deal with basket tray. Make sure you're using the UL listed fittings and the manufacturer recommended fittings with that grounding. So. And they're not, it's not like the manufacturer has like this like side 100% markup on their fittings and things like that. No, they're actually relatively priced and they make sense. So just use them. And then these are just add capacity ratings. We just use the tables as we would. Building combination and capacity of mean voltage. And then construction, strength and rigidity. Smooth edges, corrosion protection, side rails, fittings, and non-metallic cable tray. I do want to say real quick, cable tray fittings is not what you think. Fittings can be as part of the raceway. So fittings would go into like your nineties. They call them T's, they call them X's. They call them either Y's or vertical T's. There's a whole range of them. In fact, splice plates are for these trays are not considered fittings, they're considered hardware in the manufacturer's eyes. So that's what I mean by fittings is it's essentially the raceway, but they are specific to whatever it's going. So 45s, 30s, all of the above. Typically out of Supply, we make our own. We try not to buy the 45s and 30s because they never work out usually. So. Does anyone have questions on cable trays?
Guess I just kind of have a question about the bonding of it. Just popped in my head. Is it really not technically grounded until we put the clamp on? Because then we're like drilling through steel, like clamping in
Okay,
to the steel itself. Is it not grounded until that happens?
so what Blaze asked me is out where we work. He's asking me, when does it actually officially become grounded, right?
Yeah.
So how we support our tray, they have clamps essentially. They're just plastic clamps or fiberglass clamps. I can't remember what they're. But we drill through the angle iron and then we just clamp it like that. It's typically how we do it. For your answer, no, that is technically not grounded because you're a plastic clamp onto our tray. And then at the same time, our tray technically does not need to be grounded because it's fiberglass, right? So the reason why I say out where we work, the reason why we ground the supports of our tray is because most of it is typically built with the tray. So it's like I said previously, it is essentially another tray underneath our tray.
Yeah.
So if something happens with our tray and a cable somehow gets nicked, I don't think that'll ever happen with that cable that we use, but if it does get nicked and it hits that steel, it needs an effective ground path to ground to, right? So that's why we still run a 4/0 ground through there and then bond it. I think it's like every 50 feet or whatever. And then the other thing with some of the bridge structure that we deal with, we do have to do grounding jumpers to some of that bridge structure between those horizontals because how do I put this without bringing people involved? Their engineers believe that the bolted connections for the structure is not a sufficient enough equipment ground between them. So we need another ground that has its own bonding there. So. And it's not just one engineer, it is multiple engineers that have told me that. We have brought this up many times, just so you two know. But that's an excellent question though, Blaze, because yeah, you would think, because we technically bolt through it, right? So, but it's all fiberglass or plastic.
That only happens with the metal.
Yep, metal cable trays, you would see, we did a part of the ISU steam tunnel. I don't think, maybe Jackson Bolt might have been a part of it, but I don't think he was. But the steam tunnel in that vault, we had to, I think it was every 20 feet. Had to bond it to ground. I ended up not even using it because Idaho Power didn't want it because that's who it was for. But I ended up tearing it out, but that's besides the point. But yeah, we did have to do that in that instance. You'll also see in some high profile server rooms that we've been in that are bigger than this room, all their ladder tray above their server racks is all bonded. So. Yeah.
Thank
you. Any other questions? Okay. Well, what do you guys think? Call it a night? Okay. All right, everyone. Everyone have a good night, and if you have any questions, let me know. Just email me or whatever. I'll bring it up next class.
Thanks, John.
Yeah, thanks, Jackson.